So here is a walkthrough to put all of the pieces together. We'll stay high level and just do it in English before we see how it's done in code. So as always, the recursive resolver asks our favorite question, what is the IP address of eeks.berkeley.edu? And the root name server replies in plain English by saying, I don't know the answer. Please talk to this .edu name server. Here's their name. Here's their address. Same as DNS. No change. The new thing is a signature on the .edu name server's public key. This is saying, well, you trust me, the root name server, and I am including a signature on the next name server's public key. So if you trust me, now you trust them. Anything signed by this public key is now trustworthy as well. So you've delegated trust from the root name server to the .edu name server using the same certificate structure we've always been using. And finally, the root name server attaches its own public key so that you can verify the signature that they generated. Technically not necessary because the recursive resolver probably has this hard-coded, but it doesn't hurt to attach it. So those are our three things that we include, one from DNS, two from the new DNSSEC, and they delegate trust. So now we know where the .edu name server is from this first answer, and we know they're trustworthy because we've said here's a signature on their public key. So we know anything signed by this public key is good. So now we can go to that .edu name server, ask the same question, and the .edu name server would reply with three things. Again, the first thing is the same as normal DNS. I don't know, here's the next name server. They're a berkeley.edu name server. Here's their name, here's their address. Same as always. The second value is a signature that says, not only am I redirecting you somewhere else, but I'm going to prove to you that they're trustworthy. And the way I'm going to do that as the .edu name server is I'm going to sign their public key. You trusted me, and you trust anything signed by my key. So if I sign their public key, now you trust them too. This key is now trustworthy as well. Anything signed by this key we know is good because .edu has passed trust to this public key. And finally, .edu name server provides its own public key so that you can verify the signature above. So that's our second step. So now that we know where the berkeley.edu name server is, we can go to them, ask the same old question, and this time the berkeley.edu name server gives us an answer. Here's the answer. It's an A-type record. It's got the IP address of our requested domain. And like we said with our first dig idea, whenever you send information like this, you'll sign it. So here's a signature on that A record, and that's new. And as always, here's my public key so that you can verify the signature that I provided. So that's it for a high-level DNS lookup. It follows the same idea as regular DNS, but you're delegating trust using certificates, and you're verifying records using signatures.